Assalamualaikum warahmatullahi wabarakatuh. Today we will continue on lab 2. So for lab 2 is chapter 5, okay, Arithmetic Circuits. So I will show you how we can draw the parallel adder circuit, right? So we will draw this circuit, okay, by using this device, okay, 7483, okay, which is the 4-bit full adder. Okay, so if you refer to this diagram, okay, so based on this diagram, we will use 4 full adder, okay, 4 full adder because we are using 4 bits, okay, but in circuit maker we only need only one device, okay, because in this one device will represent all 4 bits, okay, for both variables, okay, for A and also B, right? So I will show you the process, okay, how we can draw the parallel adder circuit for 4-bit. Alright, so first we need to add the device. So we need the 4-bit full adder. So actually for 4-bit full adder, it's not listed in the hotkeys 1 and hotkeys 2. So you can browse or you can search. Yeah, for example, I want to search. Yeah, you can search by the number or the name. Yeah, so based on the notes that I've shown you in the slide. Okay, the ID code is 7483, so you can search by the number, 7483, and then you click find. So it will list down the device. So this is the device, so you just can double click for this device or you click place. Yeah. So I place here, okay, in the middle of the board. Right, so this is your 4-bit full adder, so I set the bigger size, right? Okay, so each device have their own designation, so you can remove or you can disable the designation. You just right click and then you click edit device. So the designation is U1, so you just click the visible. Alright, so next is actually we need to connect your C-in with 0 because based on this diagram, okay, the first full adder you must connect it with 0, because for previous that I have told you, for the first column here is actually non-value, there is no value on top of A1 and B1. So that because we are using the full adder, okay, so full adder we have 3 bits, right? So that's why we need to connect your C-in, okay, is equal to 0. So your C-in must be connected to 0, which is we need to use the ground device. Yeah? So the ground, okay, you can find at hotkeys 1, okay, ground, okay, you just put here, okay, so this ground will be connected to your C-in. Alright, so next we will insert the input, okay, for A and also B. So we will use input that easier to enter the value, okay, which is we will use the hex input. Okay, you go to hotkeys 1, okay, and then you choose hex key. Okay, so we will use hex key as your input device. Okay, instead of we are using the input switch, okay, the switch, logic switch, so we are using the hex key. We need to enter 2 hex key because we have 2 variables, right, for A and B. Right, so this one we can rename, okay, for A or B. Okay, so rename as this one I want to rename as B. Okay, and then we can copy, okay, Ctrl C and Ctrl V, and we put another one here. Okay, this one is for A. Okay, edit device data. Okay, and then you replace by A. Okay, so that is for input. I will show you the connection or the drawing for wire after this. Next, we need the output. Okay, for the output, I want to use two kind of devices. Okay, two type of devices. The first one is the LED, which is the logic display, and another one is hex display. So hex display is easier for us to see the value when you perform the addition. So you will automatically display the value for the user. Okay, what is the value after you perform the addition? So we can look at the display part. So the first one is actually I need to insert the logic display because we have four value of sums S1 until S4, so we need to have four LED or four logic display. Okay, so hotkeys 1, so we have logic display, right? So we need to put 4 here. Okay, 1 for each S. So on your left is actually S4. Okay, here is actually S4. So S4. And then you need to add another 3 for S3, 2, and 1. Okay, you just can copy and paste. Okay. So another 2. So right, so we can arrange this one because when you copy and paste the number will change. So this one is S1. You need to arrange your LED just like this. Start with S1, S2, S3, and S4. Okay? And we also need another one for LED for C out. Okay, so you put here, this is for C out. Okay, so you rename as CO. So your CO value just for the extra bits, it's not for the sums result. So your sum result only for these 4 bits, okay, S1 until S4. And another device that we need to display the result is hex display. So you go to hotkeys 1. Okay, hotkeys 1, and then you choose hex display. Okay, you choose hex display for displaying the results, and then you put here. Okay, and then you rename as sum. Okay, sum. Okay. So we already insert all the devices that we need for the 4-bit full adder. So now we move to the next step, which is the drawing wire, okay, or line. Yeah. So you choose the wire tool. Right, so if you refer to the value for the input, you have 4-bit for A and 4-bit for B. Okay, as well as your hex key. Your hex key also you have 4 pin. Okay, pin 1 until pin 4. So same goes with A. So how you going to connect the wire is actually you just referring to the same value. For example, you have A4. So this A4, meaning that this A4 input, okay, must be connected to the pin number 4 for hex key A. You just follow the number. Okay, you just follow the number. So A3 must be connected to hex key A, pin number 3. Okay, and then A2 connected to pin number 2 for A, and then A1 pin number 1 for hex key A. So same goes with B. Okay, you just follow the number. Okay, so B4 is for B, pin number 4. Okay, B3 pin number 3 for B. Okay, and B2. Oh, sorry. Should delete this one. So again, okay, so B2. Okay, pin number 2. Okay, and then B1 pin number 1. So C in must be connected to the device ground. And for the output, so we use the same method, which is you just follow the number. Okay, just follow the number S4 connected to 4, and at the same time the same line must be connected to the pin number 4. Okay, before that I want to connect the C out, okay, with the LED CO. Okay, and then for your S4, so connect with the display S4. Okay, S3, okay, with the display S3. Okay, S2 with the display S2. Okay, and then S1 with the display S1. So for hex display, also we referring to the same value or the same number. So pin number 4 must be connected to the same line with the S4 line. Okay, so you can connect wherever the line is. Yeah, so S3, okay, connected to pin number 3. Okay, then S2, okay, connected with the pin number 2. Then S1 connected with the pin number 1. So done. Yeah, so as I mentioned earlier in our first lab, you have to make sure that your pin dot is enable. Okay, you must enable your pin dot, which is on your option menu, show pin dot. So you must show your pin dot before you draw any circuits. Okay, because the pin dot is important to show us that the line is already connected. Okay, because you have the pin dot here. Okay, the black circle, okay, to show you that all the line is correctly connected. Right, so next we will test the circuit. Okay, so before you click this run icon, you have to make sure the mode, okay, your mode must be changed to digital mode. Okay, so you must click the mode. Okay, from transistor it will change to AND gate, meaning that your run mode now is digital mode, so you can run. Okay, you click this icon. So we will test, for example, you want to add 3 plus 2. Okay, so you just click on your hex key, for example A. Okay, and then you can use your keyboard, for example 3. You just press 3 on your keyboard. Okay, and then for B, okay, you click and then you press 2. So meaning that you need to add 3 plus 2, and you see the hex display will display the value which is 5. And at the same time, if you refer to logic display, you're also referring to the binary. Okay, so meaning that for S1 is light on is equal to is equal to 1. Okay, so the value is actually 1 0 1 0. Okay, or 0 1 0 1 is equal to 5. Okay. So we can test another value. For example, B we change to 3. So 3 plus 3 is 6. Okay, because we are using hex key and hex display, so actually the circuit, this parallel adder circuit can perform the addition that involve more than 4 bit actually, because we are using hexa the value, meaning that you have the value starting from 0 until F or 15, right? So this circuit, okay, when you are using the hex key, okay, so you can perform the operation that larger than 4 bits. Okay, for example 3, okay, plus 7. Okay, I changed B to 7. So 3 plus 7 is equal to 10. Okay, 10. So if you're referring to the logic display, so the value is 1010. So 1010 is equal to 10. So for hex key, it will display as A. Okay, so A. Right. So B, for example, 4 plus 7 is 11. Yeah, so 1011. So for your hex display will display as B. Okay, so there are some letter in hex display that use the small letter, not capitals letter. Okay, for example, if you're referring to B, so you use the B small letter, not B capital case, right? Why? Because there are some numbers in hex which is same with B capital letter, right? So B capital letter is actually equal to 8. So that's why to differentiate between the letter and the number, so some of the letter is using the small letter, okay, not a capital letter. Yeah, so for example, for B, and we also have D. Okay, D also using the small letters. You can test. Okay, you can test this circuit. So this is how we draw the 4-bit parallel adder. Okay, by using this full adder. Okay, 7483 device. Okay, so after you complete testing and so on, so you can press stop, or if you want to make any changes, so you just press stop. Okay, so I hope you can get the idea, the drawing for full adder, 4-bit parallel adder by using full adder, okay, using the circuit breaker.